Good morning, students. This is Mrs. D. And what you see in front of you are 5 test tubes, and I'm going to show you how a serial dilution works. A serial dilution, notice it's serial as in serial killer, or a series of something, not the cereal you eat for breakfast. But the dilution, basically, we are making things more dilute, which that means we are basically taking the solute, less solute and more solvent. What we've started with today is I have 10 milliliters of water in the first one, along with 1 drop of food coloring. Obviously, the food coloring is blue. Hopefully, you can see that well with the lighter background. In each of the following test tubes, I have 9 milliliters of water. Notice this first one here. This one looks like it's a little bit fuller, but that's because the test tube size is actually slightly different. There's still 9 milliliters of water in there. What I'm going to do is I'm going to use what we call a bulb pipette. And a bulb pipette, what it does is it allows us to get the right amount of transfer and carry it from basically one place to another. Now, ideally, this is not the most expensive pipette in the whole world. These are kind of a pain to use, but at the same time, we can transfer pretty decent results. So what I'm going to do with this bulb pipette is I'm going to take 1 milliliter from this first solution. It gets a little bubbly sometimes. So I take 1 milliliter from the first solution here. I'm just going to allow that to get to 9. And so what I'm doing, there's just a little air there. Okay, so what I'm doing then is I'm going to transfer that 1 milliliter. So I'm just going to transfer that into the second thing of water. Just take it to 10. I'm going to put the leftovers back. Notice my bulb is completely empty now. And then I'm going to stir just slightly. And I'm just going to stir slightly here because I want it to mix well. I should have gotten a good stirring rod, but I just totally forgot. So it's okay. Okay, so then I'm going to take what we have here, and you'll notice it's considerably much more lighter than the first one. So I'm going to take what we have here, and I'm going to transfer 10 milliliters from here into, or transfer 1 milliliter from here into this next one. So I'm going to use my bulb, and I'm going to get it to about 9 milliliters. Okay. And then I'm going to take that and transfer just 1 milliliter. Notice after the tip, it's not graduated, so I don't know how much that is. So I'm going to put that back into the original. And you'll notice the blue food coloring is starting to mix. And so I'm going to mix some more. Notice how considerably light bluer is that a word? How much more lighter that is. Then I'm going to take 1 milliliter from this one. This is where the cereal part comes in because I keep just using the one prior to. That's all. So I'm going to put a milliliter in here from the prior one. So I'm just putting a little bit of the concentration. Notice the concentration is getting considerably smaller. This one, you can barely see some blue food coloring in there. It's still there. It doesn't go away completely. That's the thing about a serial dilution. Like, really, the idea is it still won't go away completely. It's kind of like an exponential decay in one way, where, if you have exponential decay and you have a half-life, for example, it's still never going to just go away completely. It'll approach 0. So I'm going to put another milliliter into here and then drop. And notice, I want you to notice the colors now. Notice the colors from, we had this beginning color to now, and you can almost, it is very hard for me to see the blue, if any. What I want you to see here is because we took 10 milliliters, or 1 milliliter from each, and we made it to be 10 milliliters, our dilution factor is 1/10. We can use it as a fractional value as 1/10 or as a decimal value as 0.10. So let's pretend that our first solution was a 1 molar whatever solution. Now I just used food coloring here just for sample. But what I would do is to show the concentration of the second is we have 1 molar here, we're going to take 1/10 of 1 molar here. We multiply it by our dilution factor. So we take 1/10 of this, 1 times 1/10 is what we get right here. So our solution then, here the concentration is 0.1. This is a 0.1 molar concentration. So then we take 0.1 times 1/10, our dilution factor again, and our next one is actually a 0.01 molar solution. Then we take 0.01 molar solution, multiply it by our dilution factor again. Our next solution is 1,000th molar solution, or 0.001 molar solution. I take that, multiply it by our dilution factor. This last one, where you can barely see any blue, if any, would have a molarity then in this case of 0.0001 molar solution. That is an example of a serial dilution with a dilution factor of 1.